Um, and I'll hop over to make sure we're live. It's not unnecessary because yesterday I did run into an issue. I was doing something stupid. So like yesterday I was in a mood. Maybe I can just like I'm good at this. I can take care of it. But
You got a little too cocky right there, and then
yeah.
now I'm going to humble you a little bit.
Awesome. I think we're live, so I can get started. I'll quickly introduce the session like always. Welcome back, everyone. We have the real host, Wade, joining us again, who will be teaching us how to deploy a transformer model this time. So he'll be teaching different steps involved in that and different decisions you can make. This is fourth in our series, and towards the later half, we'll have more announcements of what we have planned coming up. Like always, welcome back, Korean. Always great to see you. Like always, please keep your questions coming in the YouTube chat. Wade always asks me to keep an eye on there, and I don't want to make him upset. And with that, I'll hand it over to Wade and keep monitoring the chat.
Yeah, you don't want to see me angry. I'm like the Hulk. So let me start my share here.
I'm terrified of that.
All right, let's see here. All right, okay, there we go. So as Sanyam said, this is session 4, and just as an FYI, there'll probably be a reminder via email, but next week we're off. We won't be doing a session next week, but we'll be resuming the week after that. So just kind of keep that in mind. And today, the resources here, again, I'll include this in the slide deck. Nothing's changed since last time. So if anybody has any other interesting links that you think I should include in this for the study group, all ears. Again, these are the fastai Hugging Face kind of integration libraries that I'm familiar with. If there's other ones out there, I'd love to include it. So let me know. Today, we're going to look at extractive question answering task. And again, we're doing a deep dive starting last week and for the next several weeks, looking at section 7 of the Hugging Face, the official course. And that's where they cover the main NLP task. And those are tasks that we want to, at least as the sole developer right now of Blurr, to be able to bake into Blurr so that fastai folks can be able to train and use those models in a way familiar to fastai developers. And they're pretty dense. So as always, I'll encourage you to read those and go through the Collab. You can run each of those sections as a Collab. There's a link actually on there. And if you do that, you get a better taste of kind of how you would actually build your data sets and data loaders and train models with the Hugging Face trainer or Accelerate or just a custom PyTorch loop. But again, we'll be looking at extractive question answering tasks, and we'll be in particular looking at how to do this with fastai and Blurr. So let's go ahead and get started. And first, this is something I learned. So as I'm building this out, the version 2, I have all these ideas about how things work, and I tend to make certain assumptions about different approaches I can use, especially when it comes to pre-processing. So if you saw the previous pre-processing code, it typically it built the actual input IDs, and then we fed those into our data block. And I was relying on my assumption of how this method prepare for model works in the Hugging Face tokenizer utils module. And my assumption was wrong. And so when I was actually starting to play with using pre-processed data and using the input IDs, I found that based on how Blurr works and how the data blocks are constructed and the data loaders are built, it wasn't faithfully reconstructing the other inputs associated to your text. So like your attention mask or models that have token type IDs, it wasn't building them properly. And to get an explanation of, or to see like why this was a problem. And again, I spent like hours trying to figure out like what's going on here. And finally, I was like, okay, let's go look at the docs, not print the docs. Let me load this up a little bit. So I was using this prepare for model, and I don't know if it used to work like this or I've always been wrong in my understanding, but I thought this worked similar to how you could call the tokenizer past text and it would return a batch of data with um, all your inputs and have the appropriate padding applied and the appropriate truncation. But in trying to debug this, I noticed that this doesn't take a list of ints, right? So it doesn't take a batch of input IDs. It takes a single inputs. It takes a single list of input IDs. And so it really, so I'm a little bit confused about the purpose of this, at least that it has options for padding and truncation, and a lot of the options that the tokenizer's call method has to handle a batch of text at a time. So I'm a little bit confused. I'll probably have to hit up some of the Hugging Face folks and ask, well, why doesn't this take a list of input ID or a list of input IDs or a batch of input IDs? But nonetheless, it doesn't. And that means that the approach I was trying to build into Blur for pre-processing data and saving input IDs and then using those when we construct our data block isn't going to work. So that was a painful lesson in reading the documentation and also some late nights. I didn't have any chai, so I had to unfortunately resort to coffee. So sorry for that, Sanyam. But anyways, so we still need pre-processing, and especially we're going to need it when it comes to question and answering, but we may want to use it in other tasks as well.
What if you had chai while designing the original API? Maybe you wouldn't have run into the issue.
I've thought about that. So I think when I start doing the summarization and translation bits, I'm gonna turn to chai and see if that solves all my issues. If it
We did
doesn't,
it, guys.
you're gonna hear about it. So
Awesome.
yeah. So anyway,
Sorry to distract you.
yeah, and this is something like when you're developing a library, and there's a lot of complexities with some of the pre-processing when it comes to using transformers. So this is one of the things that it's good to uncover now versus having to deal with later. And let me show you the fix here, or I should say a potential fix. And as we go through today, I don't have a Collab. I'm actually going to be looking at the code base and the notebooks that I use to develop Blur. And so Blur is built using NBDev. And so NBDev is awesome because you can iteratively build in a notebook, and it will create your modules. It will create your documentation. You can bake your test right in. So it's really nice for not having to jump through a bunch of different hoops to be able to build a library with tests and with documentation. You could do it all in a familiar format in Jupyter Notebook. So again, we're going to look real briefly at the changes happening to pre-processing. So essentially, with Blur, we can't use input IDs. And that means that we're going to have to, our pre-processed data is going to have to be the text that we want to feed into our data blocks. But what happens when we want to do things like create a pre-processed data set where we set the max length to 20, right? We have to actually go through our raw text and figure out, okay, what are the appropriate 20 tokens to keep? And then we have to decode those back to text. And so I came up with a creative way, I think, of doing that. And I'm using some of the capabilities of the fast tokenizer. And we won't spend too much time really looking at the pre-processing in depth for classification and for token classification. I'm going to check these bits in within the next 24 hours, and I encourage you to take a look at it. But essentially what we can do is we can apply tokenization to a batch of data right here. And this is going to give us, based on whatever tokenization arguments we've created, it's going to give us our inputs. And our inputs are, we're going to look at, we need to take those inputs and figure out, okay, how do we actually build the text that we want to ultimately use in our pre-processed data set. And to do that, we can actually look at the offset mappings. And again, the offset mappings are for each token. It tells you the start and end character for those tokens. So let's say we're truncating to maximum of 20 tokens. Well, using this particular block of code right here, what we could do is go through those 20 inputs or those 20 token IDs in the inputs, and we can find the start and the lowest start character and the highest end character. And that right there is our chunk of text that we want to eventually use. And then once we have that, we can go ahead and I'm just using a data frame here. I don't have full support for data sets yet doing this, but what we can do now is go through here and essentially add this to our data set, the start character index and end character index of our raw text that we're actually going to feed into our data block. And then we can actually create a proc underscore whatever our text attribute is here. And you can see all we're doing is just using really standard, string slicing. So this is it's going to represent our text. This is the start and end, and we do +1, of course, because we have to go. We want to get to that. We want to include that last character. And this allows us to then create a data frame that looks something like this. So previously we would have our input IDs in here, but now here I just, for the sake, as an example, have a max length of 20. And so you can see that it truncated. And so that each of these, the raw text right here, it will take 24 tokens to represent max 24 tokens to represent each bit of text. And then we can use this processed text as inputs into our data block. So that's how we're doing pre-processing right now. And you can see I'm including other things now when you pre-process. So you're getting the start character index and end character index that the process text represents. So it starts at 0 and then goes to 102. This is showing a subset, so there's actually more here, I think. So anyways, that's a major change. So just be aware if in the next day or two you get the latest V2 bits, the pre-processing has changed. All the examples in the documentation have been updated, and I'll try to go back into the Collab and fix that as well. So that's pre-processing. Let's go back to the slides here. So any questions on that, Sanyam?
No questions so far. Someone's asking, will they be receiving the materials? Yes, they'll be emailed to you, or you can join the fastai Discord to find the materials.
And that's in the slides too. And I always try to post the slides and Collab notebook when we have it on the Discord as well. Okay, so let's go ahead and get into extractive question answering. We'll look at pre-processing a little bit more since it's more critical here. So for working with extractive question answering, we are looking for a data set that includes a question, a context, and information about where to find the answer in the context. And so this is a bit different than with open-ended question answering, which is you can have a question asked and an answer being given that isn't in a particular context. And for those, we'll potentially, if there's interest, we can look at how to actually build one of those models. And we would use more of an encoder decoder model for that, something like BART or T5, since the task is very similar to something like summarization or translation. But here we're actually looking in a block of text, the context, and we want to see if the answer is to whatever the question is posed is in there. And if it is, we want to be able to extract that. And so for these type of tasks, our data set, we need to also be able to know what are the start and end character indices of the answer in the context. And a good example of this is Squad and Squad v2. The version 2 Squad data set actually also includes unanswerable questions. So if you wanted to, in addition to just figuring out the start and end tokens in the answer, you could also add a third task, which is just a simple classification. Is the answer in there or not? Is it answerable or not? So those are two data sets to look at. So just like usual, after we get our data set, we are going to use blurr.getHFObjects to get our Hugging Face objects. You can also do this manually. And the next thing to think about, we have a good data set, is what are the best type of models to use for extractive question answering? And I'm going to let you all guess. I'll give you just 15 seconds. And Sanyam, you could tell me what the top vote is. Or if there's no top vote, I'll work with either.
I'll vote if there are no votes, but I'll wait for others to come.
All right. We'll see how much you're paying attention to these study sessions.
Are you doubting me, Wade?
Oh, I don't know.
I might be wrong. I'm being cocky. I might be wrong.
We'll see. Chai is on trial right now.
Chai is on trial.
So what do you think, based on what you have learned and know about the different types of transformer architectures, would be the best architecture to choose for an extractive question answering task? What do we got, Sonia? Anybody brave enough to throw an answer out?
Okay, there's like a 30-second delay between when the time you say someone listens, then they type it back. So like whenever I do this, there's like an anxious wait that I have to go through.
All right.
Money says Bert, Robert Art is still Bert.
All right. Those are all good ones because they're from the right core architecture, which is the encoder only models. So
I was going to say that one.
Yeah, I know. You got real quiet. You're waiting for the green box over there. And then it's like, yeah, that's the one I was thinking of. So yeah, when you're building these, also think about what are good architectures to use. And that will help narrow down at least your model selection. So for extractive question answering, encoder models that bake in a really rich representation of the inputs are good for these type of tasks, whereas decoder only models are good for text generation. Typically, like GPT-2 are focused more on text generation, and the encoder decoder models, sequence to sequence models like BART or T5 are good options for things that generative tasks that also require a good understanding of both the inputs and the outputs. So things like translation or summarization. So I'm going to go ahead and we're going to look at the source code here for blurr. And again, this stuff will be checked in the next 24 hours. And you can see I'm going to work with the Squad V2 data set here in the data module for question answering. And I'm going to pull 1,000 training examples and a couple hundred validation examples. And then again, because fastai likes everything in a single data set, and then where you define a splitter to dictate which examples are associated to your training set and which are associated to your validation, I'll go ahead and just convert the raw training data set, raw validation data set into data frames. I'm going to use the column splitter in fastai and say that where you see is valid equals true. That is part of our validation set. Everything else is part of the training set. And we could take a look at the raw data. And this is how Squad and Squad V2 looks. You get the context, the question, the answers. There's our is valid attribute that we added on there. And once we have that, I am going to concatenate them into a single, what I'm going to call the Squad data frame. And now we need to be able to essentially flatten this out a little bit. So you can see that the answers come as a dictionary. So you have text, and then you have your answer start location. And notice also I printed these, I include both of these in the blurred docs because you can see that the validation data set, how it represents answers, is a bit different than the training set. So the training set is going to have a single answer text and answer start. Whereas when you're doing validation with question answering, is that you'll get several options for text, and each of these with their associated start position. And this could be one or many, or it could be none. It can be, in the case of Squad V2, there are examples that don't have an answer. And so the text is just going to be an empty list, as will the answer start. And we'll look at how to handle this in fastai, or we start modeling a question answering, or actually start training a question answering model, how this is actually used in our validation metrics. So just be aware that you're going to see a little bit of difference. What we're going to do now is we're going to use, at least as we build our data frame, we're going to actually use the first, for our validation, the first text and the first answer start location. We'll be going back to this when we do our validation metrics, and we'll look at how to get back at this information to be able to use all the potential texts or answers. But at least for our training validation set, in order to create our data loaders, to train a model, and to be able to get both a training and validation loss, we're going to go ahead and just use the first answer and the first text. And so when we flatten this out, you can see we have our data that you saw before. We have answer start character index, answer text, and answer end character index split into its own columns. And this is required for the pre-processing functionality that we include in blurr. So, and you can see that where there isn't a answer, there's the empty list. And of course, we set the start character and end character indices equal to 0. So as I mentioned, you go ahead and build your Hugging Face objects. You can use the blurr get HF objects. That makes it pretty easy. One thing that we're going to do for question answering is we're going to set a max sequence length, and we're going to make that our vocab. So in this case, we're going to have sequences of 128 tokens. And for each token, there is a prediction. We're going to mask some of those, like the tokens that belong to the question or that are special tokens, like the class or padding tokens, we're going to mask those so those don't get predicted or factored into our loss. But we start with 128 potential labels, and that's going to be our vocab for both our start and end token indices. So again, with the pre-processing here for blurr, is that it's required for question answering. And the reason is that our labels need to be the start and end token indices. And right now, what we have is the start and end character indices. And so we have to pre-process our data. We have to go through, tokenize it, and also in order to figure out the start and end token indices so that when we actually build our data block, that's what we use. Another reason that we want to pre-process the raw data is that we want to be able to handle documents longer than our max length. And again, the max length is going to be dictated by what you set specifically. So in the example that I just showed you, we're setting it to 128 tokens, or by the max supported by whatever model you're using. But we have to use pre-processing either way to be able to find those start and end token indices. So make sure you keep that clear, because sometimes it's confusing when you read the documentation. They talk about start end indices, and it's unclear sometimes, are they talking about the character ones or the token indices? Just remember that you start with the character indices, but your targets are the token indices. So you need to get those, and we also need to be able to support chunking if we want to handle long documents. And with this particular iteration of our preprocessor, it does just that. And it's pretty complex. Some of the things that the preprocessing does for you is just note that not all architectures pad or expect the pad on the right side, or expect the question to come first and then the context second. There are architectures, I think it's maybe XLNet or XLM, that actually pad the other way around and switch the context in question. One thing, if you use this particular preprocessor, is that it will go ahead and do all that for you. You just pass in what your question attribute is, what your context attribute, and it will flip them as needed. It will reset the truncation as needed. So you don't need to worry about that. But if you're doing things on your own, just be aware that not all architectures operate the same way. So for the pre-processing, we're going to rely on a lot of the capabilities of the fast tokenizers. And I'm going to go through this pretty quickly, but I really encourage you to look through it and make sure you can understand everything that's going on, as well as if you have recommendations on to improve it. I am all ears. So we're going to go ahead and look at essentially a mini batch of our full data frame at a time. And we are going to go through that mini batch or mini data frame, right? A batch data frame, I call it. We're going to go through one row at a time. And the reason we're going through it one row at a time is that when we actually tokenize our question and context, if we're dealing with a long document and we've requested that we want to have chunking done, and we'll look at how you do that. It's just a couple parameters you pass to the tokenizer. We have to go row by row because there's the potentiality that each example gets split up into multiple rows. And we want to include all of them in our data set. So we go through each one, we're going to tokenize, and then we're going to check if we do have overflow, which means that we're going to have one to many items. If we're not asking it to handle long documents and chunk long documents into sections, with the maximum length of the max sequence length that we specified, we're just going to have one example. And we're going to use the same process here, whether it's one example and we're not handling documents, or we have multiple examples generated from the tokenization of just that one row. And so again, remember, we're not going to be able to use input IDs. So what we have to do is use the offset mappings, use the sequence IDs in particular for figuring out what part of our inputs represent the question and what part represents the context. And again, this will be different based on how your tokenizer actually does the padding. So what we need to do is, once we process this, we need to figure out, okay, what are the question offsets? What are the context offsets? And then, just as I showed you before with the sequence classification, is we need to now figure out, okay, in our question column and in our context column, what is the span of text that we're actually wanting to include in our preprocessed data set. And we do it the same way, but we do it for both our question attribute and our context attribute. And that gives us the text. So if we're chunking, let's say we have a document that's like 750 tokens, and we're saying, you know, we want to chunk that in 128 token chunks. So we're going to have a bunch. We're going to have, you know, I don't know, 6, 7, or no, maybe less. I didn't know how much. I'm not good at math. We're going to have a bunch of examples, right? And so this is going to allow us for each of those chunks to get the correct piece of the questions and the context. Once we have that, we have to remember this stuff's all been tokenized. And if we just use this as is, it's not going to give us the raw text that we need to be able to feed into our data block. And also our token indices are going to be off. So what we have to do is take these process, question, and context from our these sections from our raw data, and we have to kind of go through this process again of tokenizing them, finding the inputs for the chunk, the question mask, getting the actual inputs. And if you look at the course documentation, they have a pretty complex way of figuring out where the start and end token indices are. I actually use this approach right here, which has at least proven, as far as my testing, a little bit more easier to understand, definitely much briefer, and also more reliable. So trying some of their notebooks with some of the other architectures, and what they have in the course documentation, didn't give me correct results all the time. There were little weird exceptions here and there, but this is how I am doing preprocessing, at least in Blur, and finding those start and end token indices. And you can see that we're iterating through the tokenized chunked text, right? Which is going to be potentially be a portion of our question and context in our original raw data set. And I'm going to make sure that we're not looking at a question token, because remember, we want to find the answers in the context. I want to see where the first token is the starting token for the answer. And if we actually look at the token input from that place all the way to the length, right, we can check to see, yes, is that the tokenized answer? And if it is, then we go ahead and assign the start and end indices, and we're done. And then we can simply create a new row that, again, we're using a data frame, includes our raw data, and now we're going to add a processed version of our question attribute, and our context attribute. And then we're also going to include the answer start token index, answer end token index, and we're also going to add a is answerable. So we're not going to use this today, but if you were actually using Squad V2 and you wanted to both predict, is it an answerable question as well as the start and end logits, this is going to be part of your pre-processed data frame once you run your original data frame through it. So again, look at that code, but let's focus more here on the output. As an example, I am going to say I want overflowing tokens. I want a max length. Remember, this is set to 128. Another attribute you typically want to include when you're chunking examples is stride. And stride is how many overlapping tokens to include in each chunk. And this is helpful because it gives us a little bit more context when we're actually looking at answers, so a little bit more context or repeated context for the models to actually learn from. And we're also going to pass in a ID attribute, because when we're chunking, when we go back to building our metrics and figuring out how good our model is, we want to aggregate by example. And as I mentioned before, one example can be split into multiple chunks. So how do we get back to that? And the way that we get back is by using a unique identifier for each example. And so we have to specify that here. And you can see that when we pre-process it, again, we're not getting input IDs anymore, but now we're getting just the text. And so you can see here is an example that was chunked. So, right, we're looking at this 9063, and this is one example. We keep the original context question answer. We have our is valid attribute, and we have our character indices and answer text. But we also have now a process question, process context, our start and end token indices, and whether or not the question is answerable. And if you notice, based on this architecture we're using, which paths to the right, we never want to truncate the question. So you can see the question in each chunk is still the same. But you'll notice here, if we look at this portion of the process context, this is the beginning of our raw context. And then you can see the next chunk actually includes some padding and then is a subset of whatever is in here. So that's how chunking works. And this is what we're going to pass to our data block. This process question, context, our start and end token indices. We also have tests in Blur. So it's pretty complicated, the code above. Again, I'm open to any recommendations, but at least it works. And so we actually have tests that goes through here, and for answerable questions verifies that if we decode our input IDs and we use that answer start and answer end token indices that we created above, that we get the correct answer. Here's another example of where we don't want to chunk long documents. Here, we just want to truncate them. And so you can see that instead of getting multiple examples with the same ID, here we have unique IDs. It's just that everything is truncated. And so the process question is just the first 128 tokens represented by this context here. And we got the same information. So if you don't want to use chunking, you don't have to. So for question answering, we have to pre-process the data, and we have to figure out, we have to create processed question text, process context text, and then also find our start and end indices. So, any questions on pre-processing?
People are saying no questions, but Korean was critiquing your code a bit. So
Oh, good.
Korean says, looking at the code, he was a bit confused since there were like three for loops for
Yes.
calculating start token. Korean is a software engineer, so he's upset because this would have, I think, n cube complexity.
Yeah. I share his upsetness. So I am, yeah, Karen, take a look at it. If you have some improvements on this, I am, like I said, all ears. I'll check, this will all be checked in the next 24 hours. And so feel free to submit a PR. But yeah, my approach initially is essentially to get something working and then go back and refactor it. So I am positive you're right that there's ways to improve this. So yeah, so let me know.
Awesome.
Anything else?
Just that critique.
Yeah,
No
yeah.
other
No, that's
questions.
good. I appreciate that. Yeah. Okay. So we have a pre-processed data set, and now we are going to build our data blocks just like normal. And we have two options is here with question answering is that we can build our data blocks in the usual fashion. So kind of use the standard fastai bits, the item getter or call reader for our get X and get Y. But remember, if we chunked our data set and one example is now chunked into, let's say, 5 chunks, when we do question answering is we want to build our metrics. We want to aggregate those chunks and do our metrics on the full example in order to calculate how well our model's doing at finding the answer. And so if you look at the course documentation, you'll see ways that at least they propose to do this if you're using, for example, a custom PyTorch loop or a trainer or accelerate. But here with blurr, one of the things we can now do is we can pass other things we want to include in our batch and then use those things. For example, in our training to be able to get at certain extra information. And so for question answering, when we're training and we're actually building our validation metrics, we want to, for example, have that ID attribute at the very least. And so we can actually use a dictionary as our get X, and any extra information you put in there is going to be included in our inputs dictionary. So remember, our inputs dictionary has our input IDs, attention mask, and so forth. If we use a dictionary as our get X, it will take those other things we pass and also include it in there. So let's go ahead and take a look at how that works. And now we're going to start looking at actually training a question answering model. And so here I'm looking at the modeling module for question answering in blurr. We do our pre-processing that we just saw. And now we go to, okay, let's go ahead and build our data block. And so most of this stuff is, should be pretty familiar. Remember, we're going to be predicting a start and end logic. So we use 2 category blocks, and they're each going to have a vocab of 128. And each of those digits is actually going to be the class. But one thing that's different is here, we're actually going to create a getX method, and this is going to pass a dictionary. And the only required attribute here is text. So you don't have to pass in extra information if you don't want. But this is our the actual things that we want to tokenize. And if we have 2 things, we actually include them in a tuple. So we're going to include our question and our context. And then I'm also going to pass along the ID of each of these items. And again, this is so that we can get to those IDs to aggregate our chunks by example rather than just for a particular chunk. So we can go ahead and build a data block like this. Just so you can see, it's always helpful to kind of look at, in this particular type of example right here, we have multiple targets, what the vocab looks like. So you can see we have two items, and here's the vocab for our start logits and our vocab for our end logits. And again, it's 128 options because that's the max length that we specified. Again, we can go ahead and do a show batch. And if you're interested, you can go back to the data module for question answering and see how this is implemented. But what we can see here is the full text, right? So the full text is our question plus the context, okay? And here we're using chunking. So you can see here, this is repeated, right? We have the same question, and you can see the context is a little, has some overlap, right? With this right here. And then it includes some new information. And we also, in the show batch, have a column for found, whether or not the answer can be found in the context that we have in the particular row. And if it can be found, what are the start and end token indices? And also, what is the expected answer? And so that's our data block, right? So we have that. We have our data loaders built. Now, this is where it gets fun. When we define our learner, nothing's going to look too crazy there, but our metrics are very different because we're dealing with chunk documents. And if you go through the course, you'll see it is complex to be able to go through it and be able to aggregate by example. And if you don't like for loops, you're not going to be happy with that code either. And it probably could be better as well. And I'm not sure if the course is implemented a little bit different than the actual code in the Hugging Face library. But you'll see that it's equally complex. It's worth going through to kind of get an idea of why it's complex and what they're trying to do. But the metrics is going to be tough because we can't just say, okay, here's a row from our validation set. What's the accuracy in terms of the ability to pick the right answer? Because now we need to aggregate by examples in the case that we have long documents. And again, if you go to this link here, there's this task page, which is really helpful for just any task. And we look at question answering. We'll see like proposed data sets to use and also what are the recommended metrics. And so since we already have a dependency on transformers and data sets, one that we can use is the squad metric. And just as a note, there's a squad and there's a squad V2 metric. Right now, we only support the squad metric, which assumes that there's an answer. The squad V2 also has basically a little different format that we feed into this when we compute the metric, because it also wants to know the probability that we predict for the answer not being there. And so we don't have that supported, but that will be at some point. So we're going to use the squad metric, which again expects that we're going to have and every question in our validation set is answerable. And it's going to return two things. It's going to return the exact match. And so it's going to look at what we predicted. And remember, the validation set is going to have one or many potentially correct answers. It's going to look to see if we match one of those. If there's an exact match, it will be a 1. If it's not, it will be a 0. So we're looking for exact matches. The other one that's going to calculate for us is the F1 score. And again, that's the harmonic mean between precision and recall. So it kind of balances both of those metrics out. And it's going to calculate that based on each word in the predicted sequence against the correct answer. So here's our question. As fastai developers, how are we going to properly aggregate the scores by examples when the inputs are chunked? And what do you guess? Any ideas? I know Sanyam's been with fastai for a long time, and so he probably has a good idea of what the answer is. But before we look at it, let's give folks a little bit. And also, are there any questions before we look at how we're going to do this in Blur at least?
No, there was just a discussion. Everyone didn't accept your challenge. They agreed to the fact that simple approaches are good. Korean
Yeah,
denied your challenge to raise a PR as well, and he said simple is better than complex.
yeah, totally agree. Yeah, my background is full stack web development, and so yeah, actually, I don't like complex code or like overly cute code that does something but it's hard to read. And at the same time, I know like I got to get things done. So sometimes I build stuff and I just go, oh my gosh, that is so ugly. But at least it works. And once you have something that works, then you can refactor it and improve it. So yeah, heartily agree. So any guesses on how we're going to do this? I'm going to show it to you. It's not in GitHub, so don't look there and
Let's
cheat.
give them another second. Let's
All
give
right.
them another few seconds. I always worry, like when I ask questions, like first of all, there's a delay because of the live stream, and then
Yeah.
people take a while to answer, and I'm like anxiously getting nervous. Should I just move on? And then I go back and watch the recording. It's not that long if you like see it from an audience perspective.
Oh, that's funny.
Matteo says it should be some sort of a weighted average. So,
Okay.
Matteo, are you leaning towards F1 by that?
Well, I'm actually thinking kind of more like what is the mechanism? It's a fast AI mechanism that we're going to use to be able to aggregate our chunks back by example. So it's actually a mechanism in fast AI that's going to allow us to do this.
The safe answer is callbacks, everyone. It's a
We,
callback mechanism.
we're going to build a callback. And so I hope this will be interesting to folks, because if you're doing anything with fast AI and want to move beyond, kind of like the high level API or even like some of the basics in the mid level API, and you want to do something interesting that's not in the library, the only two answers are typically transforms and callbacks. And callbacks are immensely helpful. I have a link to the documentation. You can see some of the built-in ones there, but I use them all over the place in Blur, and just about anybody else that has created some type of library on top of FastAI actually uses callbacks to do just all kinds of interesting things at just all the different parts that a learner goes through in terms of pulling data, training, validation, and so forth. So important concept for anybody that's doing fast AI development to understand. So let's take a look. So one thing is we have this simple question answer model callback that extends our base model callback. And remember, this callback right here simply just gets our predictions associated to our learner. We set them in a way based on whatever we get from the Hugging Face model output. So they actually provide an object. I'm going to go here to take a look at it. By the way, using VS Code to do notebook work is like unbelievable, like the debugging and whatnot, being able to like find code. So you can see, remember that base model callback that we probably covered a long time ago allows us to take what the transformer model gives us in the form of a model output object and assign that to our predictions. So for example, if the model outputs included a key called logits, that's our prediction generally. So we assign that to self.learn.pred so that fastai continues to work correctly with it. And in the case of question answering, we're actually going to get a couple things back. We're going to get the predicted start logits and the predicted end logits. So we're going to assign pred to this tuple right here. Before we get to the really fun callback, we also got to think about how we're going to calculate loss. And so when you read the course documentation, they don't really put a lot of value in calculating a validation loss. They put more emphasis on the metrics, and you can see how that plays out. I still think that since we're actually chunking data and we have a validation set, I think that it's worthwhile to calculate a loss for both our training and our validation. And I have this metric that I built. So in fastai, you can also build custom metrics. And if you want to see an example of what one looks like, you can look at multi-target loss. And essentially what this class does, it allows you to take for multiple targets, you can define the different functions you want to apply. So you can actually combine cross entropy with regression. You could have 1 or 2 targets. You can have 3, 4, however many more you want. You can weight the results of each of these, and then also define how you want to reduce those scores. And so essentially what we're going to do in question answering is we're going to get a loss for both our start and end logic prediction, and we're going to average that, and we're going to call that the loss. So we have a metric that's going to support both of those categories that we're trying to predict, right? Our start and end. And now we're going to get to the fun stuff, and I'm sure there's going to be all kinds of good recommendations for me to reevaluate some of this code. It's not going to be pretty, I'm forewarning you, but it works. And we're going to start with that squad metric, right? So that's something that the Hugging Face tasks said to use. They use this in the course. And just be aware that this is only going to work where our validation set actually has answers. So again, if you are using squad v2, there's going to be some examples in our validation set that don't have an answer. And so this code right now will not work for squad v2, but it will in the next few weeks. So question answer callback. And we're going to use this to actually build our validation metrics. And so what's kind of cool about fastai and whatnot is that all kinds of like ways to be able to do metrics is one, you can actually build a custom metric based on some of the base classes for metrics in fastai. But I actually created this particular metric, which we just call value metric. And it's a way for us to calculate metrics in a callback, where the callback does the work, and then we just want to tell our learner metrics, here's the metric name, and here's the value. So we'll see how this actually works right here. And this is essentially, if you want to actually do metrics in a callback, this is the approach that you're going to want to take. So the things that we're going to actually return is that exact match and F1 score that we talked about before. And we're going to create a custom metrics dictionary. And we're just going to set each of these keys up with the value of none. And then we're also going to include this do setup equal to true. And essentially what that means is that if there's code that we want to run one time and get some other information from our learner, we could go ahead and put that in a setup function. And then again, these callbacks, we have all these different hooks, right? So, or event handlers. And so the before fit handler is going to start before we start actually fitting our models, just about anything. And if you're interested on the life cycle, if you go to the fastai documentation, you'll see all the different hooks, all the different events that we can go ahead and create a handler for to be able to do whatever. And this gives you kind of a rough idea of the order. So again, we're going to start our stuff by looking at the before fit, which happens really early in the learner lifecycle. And we're going to call our do setup. And then after we do our setup, we're going to say do setup to false, just so that doesn't get ran anymore. And you can see some of the things that we're doing in here is actually getting our blurr transform, right? So with question answering, we have a QA batch tokenized transform, and we're going to use this to get our tokenizer and our tokenizer quarks to be used in other parts of the callback. Then we're going to set our custom metrics. And again, we're going to use this value metric, which is a way for us to have the callback just say, here's the metric name and here's the value I calculated for you. Show it in the progress as you're training. And then we're going to tell the learner about that and say, learner, your metrics are now whatever you had before, and also these custom metrics that I'm including here. So because this only makes sense at for our validation set, right? That's where we want to calculate our metrics. We need to use the before batch and after batch hooks, but we don't want them to run when we're training. And a simple way to do that is we can see if we're training, or we don't want to use them when we're doing inference. And in that case, there would be no targets. So using this code right here, we can ensure that this before batch and this after batch is only going to run when we're looking at our validation batches. And notice that, remember, we talked about passing extra information in that dictionary. With this particular callback, we can pass our data set, right, which is going to be our data frame. And again, this is working right now. This is going to be better. There's some things happening in the code that I kind of have hard coded that will become more argument driven. But we're going to pass our data set that we're using in our data block, right, which is that squad data frame, the attribute of where the ID is, so we can aggregate our chunks by ID. And then we're going to follow the code from the course documentation pretty much. And we're going to consider the 20 best predictions for our start and end logits. So we have to capture this information before batch, this extra information that our model's not going to use, because this is not going to be available afterwards. So using the before batch hook, you can see that I'm actually, for every single chunked example coming in, I'm going to get the ID attribute and I'm going to get the inputs. And I am, after every batch, I'm going to essentially create this results list, and it's going to have a dictionary for each batch. So each batch right now we have it set up for a batch size, I think, of 4 or 8. And we're going to create a dictionary so that we can do this aggregation that includes the example ID, the inputs associated to the chunk, the start logits, and end logits for that chunk. Okay, so again, we're going to have, if an example was broken up into 4 chunks, we're going to have 4 records in here with the same ID attribute. So we're going to do that in our before batch and after batch to be able to get that information. And before validate, we're going to make sure that our self.results is an empty list, and then the before and after batch will populate this. And after validation's all done, there's another convenient hook called after validate. This is where we want to do our aggregation. And if you don't like nested for loops, get ready to be very unhappy. But this is from the course. There's probably ways to clean this up and make it more efficient and cleaner. But I just wanted to put something in there that at least initially was working. And again, there's some ugly code because we just want to look at the validation set, right? So here I'm assuming it's a data frame and I can do this type of syntax. This isn't good. This will change, but it's in there right now just to be able to test things out and make sure it works. So you can see we're going to go through each of the chunks here, and we're going to create this dictionary. And the dictionary is going to have a key, which is the example ID, and then it's going to have the index of each chunk from this self.results list. So that we can go find, for each example, find the chunks that we should look at. Then what we're going to do is actually go through each row in our data set, get the example, and get the process context, right, that we created when we were pre-processing. And now for each example, we want to look at all the different chunks and see which ones are going to give us the best, which one's going to give us the best answer prediction, the best start and end logits prediction. And so we're going to go ahead and use that information that we actually captured in that self.results list. We're going to use the input IDs, the start logits, and the end logits to do this. And we're only going to look at the in best. And again, this is from the course. I modified this a little bit, but this is pretty much exactly what you see in the section 7 of the course for question answering. So we're going to consider the by default the 20 best start indices, the 20 best end indices. And now we're going to go through here. We're going to make sure that we're not adding a potential answer if there is no answer, or if the answers have a length that is either less than 0 or it's greater than the max answer length. We're not going to create a potential answer. So here we're looping through all our start and end indices, and again we're just adding in the 2 probabilities to give us an overall probability, which we're calling the logit score. And again, we're using those input IDs that we captured in our before batch to do decode and actually find the answer text, because the metric needs to that we're using, that squad metric, is going to require the actual text. So we can actually capture that information here, and what we're at the end result, after we process a single example, we are going to have a list of potential answers. And we're going to do that for every example. But for each one, we're going to, after this, we have those potential ones, is actually figure out what is the best answer. And we're going to append that to this predicted answers list. And it needs to have this format, which is our example ID that this is referencing, and our prediction text, right, which is going to be the best answer text. And so the answer that we have with the highest score is going to be the one that we select here. If there are no answers, we just sent this equal to an empty string. So once we've done that for every one of our examples, right? So for every example, we're looking at those chunks. We're figuring out, okay, for given all those chunks, what is actually the best result we have, and we're going to use that for our validation metric for that particular example. We then need to compare that to the reference or theoretical answers, which, yes, this will be changed, but we're looking at the validation set, and we want to compare that to these particular IDs, and the answers is going to have that dictionary, right, that has the one or many text attributes, right, for potential answers, as well as their start characters. So that's going to be our theoretical answers. And the reason we're doing this is because this is what this squad metric expects, is this type of format. And so we can actually call the squad to, and it's really the squad metric. This will be renamed when this thing is pushed to GitHub. But we can actually then calculate the metrics based on this information. And we're going to put that into a dictionary. And basically the dictionary, the keys are going to be exact match in F1, and then the values will be the actual scores. And we can assign those to our custom metrics dictionary. And what's nice is we have this metric value. So the value metric will know to look down here. Notice this self metric value, and it will pass metric key as K, whatever that is. So that could be exact match. And what this does is when we start training, it will know like these are part of our validation metrics. And when it's looking for the value, it will call this particular method, and that will return the value for that key. So if we train, notice now we have to include this fit callback. So anything that's metrics oriented that you don't need to export and have for inference, probably better as a fit callback. And we're going to set our loss function to multi-target loss, right? Because we have two things that we're trying to predict. We want to take the mean of the loss and call that the loss for our particular training in this task. And once we have all that information, we could go ahead and work with fastai just like usual. Run LR Finder, actually do a fit one cycle. And this is one weird thing with VS Code is sometimes it doesn't show the results. So what I'm going to do is restart this, clear all, and I'm going to run all so that we can actually see how those metrics are represented. But as this is working, is there any questions, or did I thoroughly confuse everyone with that callback code, or make everyone angry with the number of loops and if statements?
No one is upset. I think we'll have to go back and study a bit. So
yeah, this is definitely more the advanced side of fastai development. So when you're doing like custom transforms or callbacks, and as I said, I'm going to check this code in the next 24 hours so that you can actually go through it and step through it and play with it and see how it works, and make PR if you got some better ways of doing what I'm doing there in my ugly fashion. But yeah, so this is a way for us to essentially, we can use a callback to, so we can essentially our data block, or our preprocessing, we can break long documents into a bunch of chunks, but we can use that callback to aggregate those chunks, per example, to really figure out how well our model is answering the example with, however long it is. So that's the purpose behind it. And it's nice because hopefully you won't have to write your own callback, and you could just use it and get the results, and then you're good to go. But it does show at least kind of one approach for doing this with fastai. And if you look at the course documentation, it's kind of weird how they do it. Like they actually train, and then at the end of training, they run the validation metrics, and the code again looks very similar to what I have. But they don't calculate a loss for the validation set. and it's not really incorporated in the training. It's kind of like something you do after training separately. Whereas in fastai, you have the training step and then you have the validation step. It's all kind of built in.
Money has a relevant question. When you are writing custom callbacks, how do you test them?
So for testing callbacks, I don't know if there's any like I don't know if there's any one best approach I can think of. For something like this, I would probably calculate these metrics outside the callback. So once you see this code, things will probably be broken up a little bit where you can actually, the code that we actually use to figure out the score will actually probably be broken out into its own function. And then that would be tested, and I would compare that the results of just running that function with, the predictions and targets work the same as when it runs in the callback. I don't know if there's any like one approach I can think of to do in the callback, and it probably just depends also what you're doing in the callback as well. Because I mean, some people are pulling out like activations. Like your the fit one cycle, that's actually a callback. So all your learning rate schedulers are callbacks. And I know for those, they test them a lot of ways. I think it's just a visual test by you can actually plot the schedule and see if, yes, it's working how you expected based on the parameters you passed to it.
It's like the one batch testing approach, right? Where you just like check on a batch and see if it goes through.
Yeah. I mean, that's part of it. Yeah. It's kind of just doing like, and that's something I think I've showed. And like what you just said is that when you're building fast AI models, it's always good to look at a batch of data, to pass a batch of data into your model and see what the output is, make sure it's expected. And then as much as you can is to just write some test inside of so NBDev has like a lot of functions from FastCore, like test equality and whatnot, to try to include those and create little mock-ups. So that might be a good approach. And obviously sometimes creating those mock-ups isn't trivial. So, but yeah, you can see here I just wanted to mention that, remember those metrics. So we define them in our callback, our exact match metric and our F1. You can see that these are now included as part of the information in our learner. So we can actually visualize that and also get those back. For our show results, it looks very similar to the show batch, except now we also include the predicted start end and the predicted answer. And you can see that at least with these examples, our model, even though we're using a really small subset, did pretty well. For prediction, one of the things that I'm working on for the next few weeks is to actually have a blurr predict QA function that return results that look just like what the pipeline, the Hugging Face pipeline returns for question answering. But for right now, we can simply pass in data, and we have to include an ID attribute. You can call it whatever you want, because that's what we trained our model to look at, examples with these particular attributes. And we can just run blurr predict to get our results. Our results will have our labels, prediction indices, and probabilities for each prediction. And again, these are the start and end logits. And with a little bit of post-processing, we can actually iterate through our predictions and see for this question right here, what did George Lucas make? We correctly get Star Wars. And we can also pass in multiple examples, multiple things that we want to do inference on. And we can iterate those over those as well. And we can see that we get Star Wars. When was Star Wars? When did it come out? 1977. What did George Lucas do? Directed and produced it. So all got good results there. We can also, if we wanted to do batch inferencing, so let's say we had a lot of examples, we can use our data loaders to create a test data loader of our inference data. And here I'm throwing in a little tricky one. Who plays Spock in the movie? Obviously, Spock is not in Star Wars, at least that I am aware of. And you would hope that we would get no answer for this one. And fortunately, our model, even with the very small subset that we're training on, we get no answer, right? So it's empty because this question is not answerable based on this context. But this shows us this is just another way that you can get predictions and then do post-processing to figure out the appropriate answers. If we wanted to, again, we're working with the fastai model, so we can unfreeze, we can fit some more and show results. Again, getting pretty good predictions for this particular model. I'm going to try to trick it again. Who plays Spock? And okay, still good. Getting an empty answer. And we can go ahead and do our deploy our model. Just like we deploy any other fastai model, we can export it. The only thing we got to do is when we export it and we pickle it, it has problems with this multi-target loss. But fortunately, we don't need the loss when we're doing inference. So what I'm doing here is just setting the loss function to cross entropy loss and then doing the export so that it works successfully. Once we actually load the learner for inference, we can set it back to this, and we want to set it back to this because this actually, even though we're not calculating a loss here, it actually does some decoding of the predictions, and these are just how loss functions work in fastai. So we include that back. We can go ahead and pass a bunch of rows in here for inference. I'm going to really try to confuse it. Who plays Spock in 1977? We can do our inference, and you can see at least still did a pretty good job, except I was able to fool this particular example into predicting that George Lucas plays Spock in 1977. And you can kind of see that maybe with more training or with more examples, this would learn that this is not the answer, but it got this one wrong. The high-level API is something that I'm working on. It doesn't quite work with some of the new bits in V2, but it will. So we won't look at that. And that's basically it. So that's how we do training and inference. And let's see if there's anything else. So again, there will be a blurr predict QA method. And that's basically it. And so these bits will be checked in the next 24 hours, and really encourage you all to go back through the course, look at the relevant question answering information. So I have links to that in the slides here to where that exists in the course, and try training your own question answering model. And if you do something interesting or it breaks, or you can refactor my code and make it look pretty, write a blog explaining to it, let us know, and we will promote it on the Twitter sphere. And as a third thing, if you really want to kind of test your fastai skills, look at the documentation for a callback and try to create even just a trivial callback that you can plug into your learner, just like the callback that I created for handling aggregating the chunks by example. See if you can do something simple just to demonstrate that you understand the mechanics and how you can use it. And there's some examples of some trivial basic ones in the documentation if you click on this link. So I really encourage you to try to do that, because it's definitely one of the more sophisticated mechanisms in fastai, and something you're going to want to probably build as you start doing more complex things, and wanting to get information in or out of your model throughout the entire like learner training validation life cycle. So that's it for me. Any other final questions? I know we're getting late here.
No, no worries about it at all. I wanted to say people are always happy to learn from you.
Cool.
I don't see any questions, so we can wrap up with the announcement that we'll be going on a break. Wait, do you want to share that?
Yep. Yeah. So next week we'll be taking a break. So we'll give you plenty of time to look at the token classification question answering bits, and also go through the course if you can. So you have a couple weeks to at least go through those particular bits, and that are in this slide and the slide before. And in a couple of weeks, we'll pick up and look at summarization and translation. And after that, we'll explore kind of really the bedrock of all this, which is language modeling, and talk about competitions and prizes and all that other good stuff.
So I have two quick announcements to tell everyone. Let me quickly share my screen 1 second and find the correct window here. I was able to grab it. So we're putting good use to the time while Wade will be away. So for the next 2 weeks, we won't have the Hugging Face session like Wade said. But next week, an hour early, so at 8 a.m. Pacific, we'll be hosting someone from the Prax framework. They'll be telling us more about it. So this is part of the Jack series if you all are interested. And we're having a fight between coffee and chai. So the Sunday after that, we'll be hosting Leticia, who has this fantastic YouTube channel. I would highly encourage everyone to check this out. Our head of data science, Brian Bischoff, his name is not Dr. Donut, will be hosting this. So as you can see, we're putting good use of the time while Wade is away. So if you're interested in joining those sessions, please keep an eye out on Twitter. We'll announce them there.
Awesome. I'm already a fan of that YouTube. I will have to subscribe just based on the name of the channel.
Maybe we should ask the loser to rename their channel
Yeah,
to what they've been with us.
yeah. We'll see how that goes over there. AI with
Awesome.
chai. Well, AI with chai's got a nice rhyme, so
I would agree with that. Awesome, everyone. Please connect with Wade on Twitter, and we'll see Wade in 2 weeks from now. For those 2 weeks, we'll have those sessions. And thanks again for joining. We'll see you in then. Thanks, Wade.
awesome. Yeah, thank you.